question is, evaluate the value of the integration of the function x plus 2 upon square root of x square minus 1 with respect to x. Now to solve this question, first of all, on observing this integral, we find that this integral is in the form of linear upon square root of a quadratic term, right? So to solve such type of problem, what do? We first of all write the numerator as, the numerator is in the form of px plus q, is written as equal to lambda times the d upon dx of the term inside the square root sign, that is a quadratic term, which is obviously would be in the form of ax square plus bx plus c plus a constant mu. So it should be noted here, p, q, lambda and mu are all constants. Okay, so what we are going to do here, we are going to substitute x plus 2 for p x plus q and ax square plus bx plus c with x square minus 1 and calculate the value of lambda and mu. Okay, so this method is quite cool, and let us see how we are going to solve it. So we are going to get on substitution x plus 2 instead of px plus q, and ax square plus bx plus c is substituted by the term inside the square root sign, that is x square minus 1. On differentiating, I am going to get x plus 2 is equal to lambda times 2x plus mu. So it's quite obvious that differentiation of x square is 2x. Okay, now we are going to solve this equation for lambda and mu by coefficient comparison method. Okay, and this method is like this. We are going to take the term of x and both sides, and we are going to equate their coefficients. So coefficient of x on the left hand side is 1, and the coefficient of x on the right hand side is 2 lambda. Okay, so on comparing the coefficient of x, I can write 1 is equal to 2 lambda, or lambda is equal to 1 upon 2, and the constant term 2 is equal to the constant mu. So I get mu as equal to 2. I'm going to substitute this value in equation number 1 to get x plus 2 as 1 by 2 times 2x plus 2. This value is going to go to the numerator, that it is going to be replaced with x plus 2, right? So I'm going to get the integral like this. On dividing the terms separately by these two terms in the numerator, I'm going to get the integral as equal to 1 by 2 times 2x upon square root of x square minus 1 dx plus 2 upon square root of x square minus 1 dx. Okay, now we assume that this integral is equal to I1, this is equal to I2. We are going to solve them separately because this would be solved by substitution method. This, you can see, it is a direct formula. So taking I1 and substituting x square minus 1 is equal to t, I am going to get 2x dx is equal to dt. So 2x dx would be replaced by dt. Here I am going to get square root of t. So I am going to get 1 by 2 times, which was there, it is written outside the integral sign, dt upon square root of t, which is equal to 1 by 2 t to the power of minus 1 by 2 dt. On integration, I am going to get this as 1 by 2 as it is, t to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1, which is equal to 1 by 2 times t to the power of 1 by 2 upon 1 by 2, which is equal to square root of t, or x square minus 1 inside the square root sign. Okay, remembering that I1 is equal to square root of x square minus 1. Okay, so I'm going to take I2 as equal to 2 upon square root of x square minus 1 dx. We know that integration of square root of x square minus 1 dx is equal to log of x plus square root of x square minus a square plus c. So here the only difference is that we have 1, here it is a square, so I'm going to treat 1 as 1 square and I'm going to apply the formula. So I'm going to get this as 2 log x plus square root of x square minus 1. So I've calculated I1 and I2. Substituting for I1 and I2, I get the value of the integral of this function is equal to square root of x square minus 1 plus 2 log x plus square root of x square minus 1 plus c, which is my required answer. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.